All right, good morning, everybody. So the goal here today is to finish our knowledge about these sine and cosine graphs. So I'm going to graph this red function using cosine and using sine. So first of all, what you should do when you're faced, you should try to start when x equals 0. That's not always possible, but you want a starting point. The midline is right here. The midline is y equals -1. So sine, if you could think of sine as having a starting point, normally sine would start at the origin, but this one got shifted down 1 unit. So you could think of sine, quote, starting at the midline, which puts me right here when x equals 0, but I could think of my sine as starting right there. It's just shifted to the right 10 units. And it would be flipped upside down because you would start going down. Or I could think of my sine function as starting right there. It's just shifted to the right 20 units. But when x equals 0, the graph, the trig function is heading through the midline at that point. So we're going to have it be sine. And since I know the midline from -1 up there to 2, the amplitude is 3, so the absolute value of A is 3. But then since you started going up, the sine value naturally starts going up, so it's +3. And then the period is, well, down, up, up, down, and then up again is 20. So the period is 20. That means you need to go 20 units before things start repeating. The period is 20. And I use that to help me find the B value. Remember, B times the period will equal 2 pi. So if I take 2 pi divided by the period, that will equal B. And in this case, B ends up being pi over 10. B is pi over 10. So I can write my function, my sine function. Y equals 3 times the sine of pi over 10 times x minus 1. That's that function, that black function will generate that red graph. Now, if I think of it as a cosine function, cosine will have a, quote, starting point either at the top of the curve, so here or here, or at the bottom of the curve. So if it starts at the top of the curve, the A value is positive because cosine would naturally coast down the hill at its starting point. So if you start at the top of the hill, then A is positive. If you start at the bottom of the hill, then things get flipped around and A is negative. So we'll start things easy and we'll just start there at the top of the hill. So I'm going to write another function that will still generate this graph, but it's going to be a cosine function. And I'm going to think of my starting point right here. So this function has the same period, right? It still repeats every 20 units. It has the same amplitude. It has the same midline. The only difference is I need to think of my starting point shifted over to the right 5 units. So I just had to add a shift to the right 5 units and also make a cosine. So 3 times the cosine of pi over 10 times x minus 5. That is a correct answer, but notice those parentheses. You see how I separated pi over 10 and the minus 5? Those are separated, just like when we learned transformations back in September. You're vulnerable if you kind of mix the transformations together, things aren't as clear. If you keep them separated like I have here, then it's very clear that, okay, this is the B value and that was shifted to the right 5. But you should also submit your answer as if you were distributing that pi over 10. So pi over 10 times x gives you that. And pi over 10 times 5 gives you pi over 2. So this is also a correct answer. Unfortunately, the bottom one is more common, and it's unfortunate because it kind of hides the transformations a little bit. I mean, this b is still pi over 10, but it would be a massive mistake to think that you went to the right pi over 2. You would have to factor out pi over 10 to get you back to this equation right here to realize that you actually went to the right 5. Let's do another one. Let's do this one. So first of all, find a starting point. And when x equals 0, I'll just start right there. So now when x equals 0, I'm at the bottom of a hill. So I'm going to think of this as a cosine function first. And my midline is 3. And that means my amplitude, oh no, sorry, 2. My midline is 2, and my amplitude is 3. But since I'm using cosine and I start at the bottom of the hill, things get flipped upside down. So my a value is -3. 1 period is pi over 2. The b value equals 2 pi divided by the period, which is 2 pi over 1 times 2 over pi. And the pi's cancel out, so the b value is 4. So I'm ready. Y equals -3 times the cosine of 4x. Don't get confused with the period and the b value. -3. That function will generate that blue graph. How can I write this as a sine function? Well, you have to pick a midline. Let's go to the left this time. So remember, sine begins at the midline. Cosine begins at either the top or the bottom, but sine begins at the midline. So we'll start there for sine. I'll change to red. Everything is the same except for the shift. So it's still, the amplitude is still 3, but since I started here, sine naturally goes up and then down. But if I started here, I would go down and then up. So my a value is, again, it's still negative. -3 times the sine. The b value is 4. I need to separate that from the shift to the left. So it's x. How far to the left did I go? Okay, now how far to the left did I go? I went to the, This is pi over 2, and I went to the left this far. So let's see here. If I divide pi over 2 in half, then that's pi over 4. And if I divide that in half again, then that's pi over 8. So this starting point to the left, it's to the left pi over 8. So I add pi over 8. And then that function will generate that graph. And again, distribute that 4, and you get 4x plus pi over 2. Just a coincidence that it equals pi over 2 again, but don't read into that. So the goal for this chapter is to, I can give you a graph, and you need to express it as a cosine and as a sine. And so when we meet tomorrow, it'll be easier when we're more interactive to generate these and work with the phase shifts. These are called phase shifts when you move left and right. This is a great exercise. So here's a function, all these starting points. You can give me functions for all 12 of these starting points. Like what if you started right here at 4? What would the function be? What if you started right here at 12? What would the function be? If you started at 12, it would be a cosine, and a would be negative. If you started at 4, it would be a sine, because it's starting at the midline, and a would be positive, because you're going up. If you started at 2, it would be a cosine, since you're at the top, and a would be positive, because cosine naturally coasts down the hill. So that's what we'll practice tomorrow. Hopefully we can do all 12 of these. But please maybe watch this video a couple of times, pause the video on the second round and see if you can finish it on your own.